Before we begin this example, let's recap what it means for a force, for forces to be in equilibrium, for a particle to be in equilibrium. So let's suppose we've got a force, a particle here, and we've got two forces acting to the right. So we've got a 2 Newton force and a 1 Newton force. Let's take right as our positive direction. Now, if we know that this particle is in equilibrium, we know that there must be a 3 Newton force acting to the left, so that the forces left and right are balanced. What does this mean in terms of if we add the forces up? So because we've taken right as our positive direction, if we add these horizontal forces together, we're going to have 2 plus 1, and then because 3 is pointing in the negative direction, subtract 3. And if we do that, we get 0. So the fact that if we add the forces together and we get 0, that means that the resultant force is 0, so the acceleration is 0. We could do a similar thing vertically. If we draw on some forces vertically, if we know that there's a force B newtons acting upwards and a force of 5 newtons acting downwards, then we know that because this is particles in equilibrium vertically as well, we know that let's take upwards as our positive direction, so up as positive. Then we're going to have B, which is a positive force, and 5 is going to be our negative force, so B minus 5. And if we add them together, we get 0. So we could solve that and we could find out that B equals 5. So obviously they're balanced and it doesn't have any acceleration upwards or downwards. So B equals 5 newtons. So all we're going to do in this example is do a similar thing, but we're going to write our forces as vectors. So in example 3, we've got 4 vectors acting on this object. So let's write them in vector form. So we've got one force of vector 2, 3, which means that it's 2 newtons to the right and 3 upwards. We've got this other vector, which is 4 minus 1. We've got another vector, which is minus 3, 2, and a final vector, which is AB. Now, because we know that these are in equilibrium, if you just look at the horizontal forces, if we add them up, then we know that horizontally, our forces add up to 0. And we could do a similar thing vertically. Our vertical forces have to also add up to 0. So you know that when an object's in equilibrium, if you add together all the vector forces, you get the 0 vector, 0, 0. So what does this mean? Let's add together all the vectors on the left-hand side. If we add together all the vectors on the left-hand side, we're going to have 2 add 4 minus 3, which is 3, and then plus A. And vertically, we're going to have 3 minus 1, 2 plus 2, which is 4, plus that B, and that's equal to 0, 0. So from this, we know that 3 plus A has to be equal to 0. And we also know that 4 plus B equals 0. So from these two equations, we get that A equals minus 3 and B equals minus